Hi, everyone. This video is going to explain slides 6, 7, and 8 from Tuesday, week 19's student practice. So I wanted to go over how do we take a graph that's given on the left side of our slide and build a relation in proper format. And from that relation, and we'll go over the definition in a second, from that relation, how do we pull apart the two sets and list the domain and range values in proper format? So I'm going to go over slide 6 and 7, and then I will show you the answer for slide 8. I want you to use this video to once again hear the process from our classes that we started last Thursday, and also be able to check your work while you're listening to this and making sure that you did have all of the correct ordered pairs and the correct notation. So on with it. I have slide 6 right here presented for you. So let's look at slide 6 and work with what we have. So given a graph, and that's what this is, we have some ordered pairs that are highlighted here for us. We're going to take those ordered pairs and we're going to break the graph into a different view called a relation. A relation is a collection or a set of ordered pairs. Remember, it needs to come in set notation, and that's why the definition had the word set. And that set notation is a brace. That brace can be located on your keyboard to the right of the letter P. You will have to use Shift to open the brace and then Shift again and press the other key to close the brace. And those are braces. A relation is the collection of all ordered pairs. So when we read a graph, we read the graph from left to right, the same way we read a book or a passage. So right here, the first point I'm going to list is right here. It's -1 on the x-axis and 5 on the y-axis. So I'm going to open up parentheses for proper format of an ordered pair, and I'm going to list that there. Since a relation is a collection, I'm going to put a comma because I'm going to list another ordered pair. Moving down, remember we're reading left to right, so this would be the next point. That would be 0 on the x-axis, 3 on the y-axis. Moving left, 1, 1, comma. Moving left to right, here we're at 2, but now we're at -1 on the y-axis. So +2 on the x, but -1 on the right. My next point is 3 on the x, -3 on the y. And my last point would be 4 on the x and -5 on the y. Now, once I build, parentheses, then end with brace. Once I build this relation, this is the set of all the ordered pairs that represented by this specific window. Yes, those points go on outside of the window I can see, but these are the ones that are highlighted within the graph. You can quickly count 1, 2, 3, 4, 5, 6. So 1, 2, 3, 4, 5, 6. I didn't miss any of those. Quick check just to make sure you can count. Now remember, the relation is the set of it's the collection of the two sets of all of the input and all of the output. Remember, the x-axis represents your input value, independent, and the y-axis is your output value. Those are the dependent. So my domain is the list of all of my x values. Now remember, your domain and range also needs to be represented in set notation. So now I have to go through, I'm going to change my pen color for you. A little bit brighter. Okay, so now I need to go through and I need to highlight all of those x values. The x values are the first value inside of an ordered pair. Remember, ordered means alphabetical. And now I have to list those, -1, 0, 1, 2, 3, and 4. And because I read this graph from left to right, my x values are automatically in numerical order. As we read left to right, those x values get larger, which gives us numerical order right off the top. One easier way to read the graph so you don't have to reorder your domain values in the end, and close that with that braces. So those are all my x values. Remember, the word about range from our notes are all of our y values. Now the y values are the second number in each ordered pair. They represent the output values, the y-axis. So now I have to list those. But remember, range and domain need to be in numerical order. And as I can see this, my line is falling. Therefore, the 5 here, my first one, is the largest. And then my values decrease. So technically, I have to start over here and read them off in my range, because therefore they would be in numerical order. So -5 is my smallest, then -3, then -1, 1, 3, and 5. And I'm going to close that up. In this case, I had no repeating x values, which verifies that this is a function, if you remember correctly. Remember, those x values are not repeating. It would pass my vertical line test, which gives me another understanding of why I had no repetition in my domain values. And my range values, I have to have the same amount of those as well. And I had no repeating here, so I didn't have to worry about simplifying this. So hopefully that's a quick understanding of our domain and range. I'm going to do the next one for you, but I'm going to do the next one with a little less talking so that you can see how I'm reading off this relation. So again, we're going to read left to right. So for my first order pair, -6 on the x, -2 on the y, -3 on the x, 0 on the y, 0 on the x, 2 on the y, 3 on the x, 4 on the y, and last, 6 on the x, 6 on the y. Close it. Start separating. -6, -3, 0, 3, 6. Again, once I read this from left to right, my domain values are automatically in numerical order. And now my y values listed in set notation, -2, 0, 2, 4, 6. Those seem to be in numerical order as well. And that is one reason why the reason why is my line is increasing. So as my line increases, it starts low on the y-axis and then builds. So therefore, it gives me a little insight into my listing of my range, and that it would be automatically in numerical order. And there you go. That was from start, given a graph, to the listing the relation, from the relation, separating the x values for the domain and those y values for the range. Each of those listed in set notation, which is beginning and ending with braces. Moving on to the next one, which I already have the answers there for you. So I quickly just want you to check those to make sure that you have the same that I do. Oh, there's an error. I just caught it. Do you see? I forgot to close that parenthesis. So make sure you go in there and you quickly check to make sure that you have the same symbols that I do. Since I read this off from left to right, my points starting at the farthest left and then moving all the way to the right, my domain values were already in numerical order. However, since my line was falling, my x values needed to be rearranged. Hopefully this video gives you a quick insight of building a relation, domain, and range list in set notation from the given graph. Have any questions? Let me know.